Okay, so this week we are going to be looking in IXL at letter H, ratios, rates, and proportions. This first part we're going to look at is number 1, understanding ratios. I'm going to go ahead and open up IXL so you guys can see what I am seeing. So we're going to go through, and in this video I'm going to go through each section, and I'll try and put a little white screen up in between each lesson so you can watch and then pause and do them as we go. So when we look at ratios, first, let's always learn with the example. The question when it comes to a ratio is, it's like asking for how many of one thing is there a smaller subcategory of another thing? Or for how many of one thing is there another of a different thing? And it sounds a little bit confusing, but it's actually super simple. But the reason we talk about it is because it really helps when we start talking about statistics and we start looking at solving problems or doing research when it comes to statistics. It helps us a lot. So in this particular question, the question is, what is the ratio of hexagons to triangles? So it's kind of like saying, every time you get this many hexagons, you'll see this many triangles. So when we look at this, we're going to count it out. 1, 2, 3, 4. There are 4 hexagons, and there are 1, 2, 3 triangles. So we're going to write it just like it has down here. I was going to go solve it, just like it is here. For every 4 hexagons, there are 3 triangles. Okay, so we're going to go back to practice. What is the ratios of triangles to squares? So we know that the top number is going to be triangles and the bottom number is going to be squares. It's important that we listen to the language and the order in which they ask the question. So we know for every 1, 2, 3, 4 triangles, there are 1, 2 squares. So 4 triangles for every 2 squares. Okay. What is the ratio of stars to total shapes? Okay. So the first number that they're asking for is stars. How many stars are there? 1, 2. Okay, so we're going to put 2. And then we're going to use a slash because we're doing 2 for every. And then stars to total shapes. So it's not asking stars to squares, it's asking stars to total shapes. And stars are shapes. So we're going to count 1, 2, 3, 4. For every 4 shapes, there are 2 stars. Oops. There are 2 stars for every 4 shapes. There we go. I confused myself. Here is another way that we can write a ratio. We can do it like a fraction with a numerator and a denominator, but this is a way you maybe haven't written your problems before. What is the ratio of squares to total shapes? So the first thing they're asking is squares, and the second thing they're asking is total shapes. So you can see there's only 1 square there, and they've already given us the second part. Okay. What is the ratio of hexagons to triangles? So, and we're going to look at the directions, write your answer as 2 numbers separated by a colon. So for how many hexagons are there to how many triangles? So hexagons first, 1, 2, 3, 3. We're using the colon. And then how many triangles? Just 1. So this can go really quickly, but you do need to read carefully and then make sure you answer correctly. So what is the ratio of squares? There's 1 square to triangles for every 1 triangle. Oops, but they asked me to write it with a numerator and a denominator, not with a colon. So 1 square for every 1 triangle. What is the ratio of total shapes to triangles? So we know the first number is total shapes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 shapes. And then how many triangles? 1, 2, 3, 4, 5. So for every 10 shapes, there are 5 triangles. All right. So you know how to do this now. I want you to go ahead and do the rest on your own. And we'll go from there in class. If you have any questions, you can ask when you come to Zoom. And I'm going to move on to the next section. So please pause your video and do the rest of H1, understanding ratios. We are going to move on to letter H, number 2, which is identify equivalent ratios. We're going to do use what we did in the last section, and then we're going to decide if ratios are equal to one another. So let's go ahead and get that open. Okay. We're going to go back to the first. There we go. I'd already opened it up and looked at it. So we are in H2, identifying equivalent ratios. And what the question is going to look like are the ratios of 16 to 12 and 4 to 3 equivalent? And so we're going to be using a lot of those skills you've learned when you've done fractions and simplifying fractions. So we're going to look here and write the ratios as fractions with a numerator and a denominator. We know from the last time we did that the numbers are, the first number is the numerator and the second number is the denominator, just like here. So in this case, it is shifting 3 to 4 to 3 over 4, and 15 to 20 to 15 over 20. And now we can compare the fractions using a common denominator, which you've done before. So first we have to find a common denominator for 4 and 20, which we know 4 goes into 20. So we can do the math there. So then you just keep solving out to see if they're equal. Okay, so we're going to do this a couple times. So are the ratios 16 to 12 and 4 to 3 equivalent? I'm going to switch over to my paper and we're going to do it there. Okay, so I've written them out here. We have 16 to 12 and 4 to 3. So the first thing we're going to do is write the ratios as fractions, okay? So the first number is the numerator and the second number is the denominator. So in this case, this is 16 over 12, and this is 4 over 3. Now we're going to try and compare them using a common denominator. So this one's fairly simple because we know 3 goes into 12. So we're going to leave 16 over 12. Just bring it on down. We're going to keep that the same. And then we know to get 3 to 12, we're going to multiply it by 4. So let's just do the math here really quick. We want 3 to equal 12, so we're going to multiply 3 times 4. And that's going to equal 12. And since we had to multiply 3 times 4, we also have to multiply 4 times 4. And that is 16. So this simplifies to 16 over 12. And we know that the two are equal. Okay, we're going to go back to IXL and do another one. Let me just get these screens switched over. Actually, I might just leave it here. No, I'll switch back over so you can see how they're written. Let me go. Okay, we are going to look at this question. Are the ratios of 3 to 2 and 8 to 12 equivalent? Okay, that's our next problem. I'm going to go ahead and write that out over on my other board, and we'll switch over to that camera here in just a second. Okay, so we have switched over to my dot cam, and we're going to look at the ratios of 3 to 2 and 8 to 12, and we're going to decide if those are equal. So again, the first thing we do is turn them into fractions with the first number as the numerator and the second number as the denominator. So this becomes 3 over 2. This becomes 8 over 12. Okay, so what we're going to do in order to figure this out is find a common denominator. So we know that 2 can go into 12. So we're gonna leave this the same way it is, and then we're gonna go ahead and turn 3 over 2 over something that we can compare with a common denominator. I'm gonna do that over here. Okay, so we have 3 over 2, which is equal to We'll do the bottom first because the denominator is what we're finding. We need to get 2 into 12. So we have to multiply 2 by 6 to get to 12. Okay, so if we multiply 2 by 6, then we also need to multiply 3 by 6. And 3 times 6 is 18. So then we have to decide, are these two equal? No, they're not. So in this answer, we're going to go and answer no. And that's the way we're going to go about doing this section. Okay, so as you continue doing H2, you might be able to just do it in your head if you can figure out, okay, well, I know 4 is going to be the common denominator. I know that it's going to be 1 times 4, that's going to get this one that way. And then so 4 times 4, it's okay, it's not gonna work. And you can maybe do it that way. So you can either, if you can do it in your head, go for it. If you can just find the common denominator in your head, figure out how many times you have to multiply the original denominator by it to get that, and then multiply the first number by that. That's a lot of steps to hold in your head. So feel free to write it down the way I just did. And then I'm gonna let you go ahead and work on this section, and go ahead and pause the video, and I'll come back and work on number 3 with you. Okay, hopefully you are ready to move on to IXL H3 right equivalent ratios. So we're going to be doing pretty much what we just were doing, but kind of in reverse. So rather than deciding, yes, this is equal or no, it's not, we're going to create a ratio that is equal to another one. For example, we're going to get this first ratio 1 to 7, and we're going to we have to use the same type of math we just did to make an equal ratio here. Okay, so I'm going to, just like you do in any one, you can learn with example. So we're going to go through and look at the instructions here, just like you should if you're working without me. Okay, so to find an equivalent ratio, we multiply or divide both numbers in a ratio by the same value. So it's kind of like finding a common denominator, but it's a little bit different. Okay, so in this case, we've been given the first number in the ratio that we have to come up with. And we have to make sure that it is equivalent to 1 to 3. So because the second number is missing, we need to compare the first numbers. So we need to compare 1 to 7. So how many times do we need to multiply 1 to get it to 7? In this case, it's a 1, so we know that we can just multiply it by 7. So in order to move on from there, we multiply the second number also by 7. So we're going to multiply 3 by 7 to get 21. And that means that 7 to 21 and 1 to 3 are equivalent ratios. That means they both actually equal the same type of ratio. So we're going to go back to practice. So similarly with this, we're going to go from 1 to 7. And that we need to switch it, or we need to find an equivalent ratio that is 6 to something. So another way you can say this is that for every one of this, there are 7 of these. So if we had the same ratio with a greater number, we would say we have 6 of these for every what of these. So I'm only giving you that language because this is really helpful when you go to talk about statistics and when we read statistics from studies. So we're going to go ahead and go to my document camera, and we'll go through it really quick, how we would do it. Okay, so we have 1 to 7, and we need to figure out an equivalent ratio where the first number is 6. So we're going to just look at these first numbers. We're going to look, I'm going to write them this way, 1 to 7 and 6 to what? They have to equal the same. So to get to the 6, it's pretty simple because this is a 1 and it helps us, okay? So if we wanted to get the 1 to turn into a 6, we would have to multiply it by 6, okay? So 1 times 6 is going to equal this number, and this is the number we've been given. Okay, so then all we need to do is multiply the second number in the ratio also by 6. So you can either write that down or you can do it on your calculator. I'm just gonna put it off to the side here. And we're gonna do 7 times 6. So if you wanna use a calculator, you can. The number that we are getting is 42. Okay, so just like you need to multiply the denominator by a certain amount to get a common denominator, we're kind of doing the same thing, but in reverse. And we're being given one of the numbers in the ratios that we need to work with. Okay, so we're going to go ahead and look back at IXL. Let me just switch back over and get to the next question. Oops, sorry for the lag. Okay, same thing. So if I was going to do this in my head, they've made this one nice because the first number is 1. Okay, so anytime that it's 1, you just look at this number. So you need to multiply 1 by 5 to get this number. So we can hold that in our head. So then all we need to do is multiply 9 times 5 to get the next number. And that's going to be 45. Okay. Here we go. This one is a little more tricky. So I'm going to go ahead and write this one down and we're going to solve it together. We need 6 to 4 to equal something by 48. We're going to move on to the document camera to do that. Okay, we are sharing the document camera. And we are looking at the same problem that we were just looking at in IXL. 6 to 4 is what to 48? So the first number is missing from this solution that we're looking for. So we're going to compare the second numbers of the two ratios. So these are the numbers that we're going to look at first. So 6 to 4 and what to 48? To get to 48 from 4, we need to multiply 4 times a specific number. So you could go backwards and divide 48 by 4, if that's helpful. But you might also know that 12 times 4 is 48. So we're going to go 12 times 4 equals 48. So then this is the number we're looking for to multiply this first number by. So we're going to multiply 6 times 12, which equals 72. Okay, so now we've found our first number. So we know that 72 to 48 is equal to 6 to 4. And that's how we're going to go about solving those ones. You guys can go ahead and pause the video and finish up section 3, and then bring any questions you have to Zoom. I'm going to go ahead and switch to number 4. So please pause the video and finish number 3 before you move on. Okay, guys, we are moving on to H4. I forgot the 4. Let's just squeeze it in there so you can remember. We're moving on to H4, equivalent ratios for, and it's going to be word problems. So we're actually doing the same math skill that we've been doing. You know, we're looking at those ratios that are equivalent or equal to one another, but we're doing it in word problems, which are my favorite. Okay, let's move into this. So this is an example of one of the questions that you might get. This is like when you first log in, you're going to see this learn with example, which we're going to go ahead and look at. But let's look at the question first. Are these ratios equivalent? 15 centimeters every 24 hours, 25 centimeters every 4 hours. Okay, we know that the unit is the same and the unit here is the same. So we can go ahead and write these as ratios like we have been and solve the same way we have been. So for this example, this is a different word problem, but it's got 16 horses to 18 cows and 7 horses to 13 cows. So the two ratios are equivalent if their cross products are equal. Okay, so we're actually going to be moving into a new way to solve this. This is similar to some of the other fraction work that we've been doing. So stay with me and we're going to figure it out. So the first thing we do is that we write the ratios as fractions, just like we have been. And then we're going to compare the two fractions to see if they are equivalent. You're going to look at the larger number and multiply both sides by 18 by 13 and then simplify. And then the cross products here are not equal, so the ratios are not equivalent. And we're going to go ahead and practice that because that's a little bit different than what we've done so far when we're looking to see if they're equal or not. You can also do the other ways that we were saying if things were equal. You can also go ahead and do that. It's up to you. So let's switch over to a white paper, and I will we'll walk through one with you. Okay, so here we are looking at one of the questions from IXL, and I went and found one that is similar to the ratios that we were already doing where we multiply both sides by the same number. So we're going to look at this first. This is the question, are these ratios equivalent? 1 pedestrian every 10 months, 2 pedestrians every 20 months. So if we were to write those as ratios, they would be, is 1 to 20 equal to 2 to 20. So when we go to solve that, we're going to write those as fractions first. 1 over 10 and 2 over 20. Okay, so what we're going to do is try and figure out if these two are equal or not, if the ratios are different. Okay, so when we have this, we know what the fractions are going to be, 1 over 10 and 2 over 20. Now what we're going to do is a little bit different. So we've gotten this far. This is stuff we've done before. So what we're going to do now is take those and write them like right next to each other. We're going to decide, are they, it's a question mark, sorry. My question mark looks weird. There we go. It's a question mark. Are they equal? So what we're going to do is we're going to cross multiply. So I'm going to multiply diagonally 10 times 2 and 1 times 20. Okay, so the first thing I have is 1 times 20, and is that equal to 10 times 2? Okay, 1 times 20 is 20, and that is equal to 10 times 2, because 10 times 2 is 20. So if we do that and we get the same number on both sides, then we can say yes. The fractions are equivalent, so the ratios are equivalent. Okay, here's another one. We're going to look at these two ratios and decide if they're equivalent. 10 wins to 38 losses and 5 wins to 19 losses. So first we're going to write those as ratios. So the first one is 10 wins to 38 losses. And the second one is 5 wins to 19 losses. So very first thing we're going to do is turn them into fractions. And rather than write them multiple times, we're just going to write them so we can cross multiply right away. So what we're going to do is write them here, 10 over 38. And we're deciding, is that equal to 5 over 19? So remember, this first number is the numerator and the second is the denominator. The first one is the numerator, the second is the denominator. So we're going to write them as fractions. Okay, now we're doing the same thing as we had done before. Okay, we're going to cross multiply. So the first thing we have is 10 times 19. And we're deciding if that is equal to 38 times 5. Okay, well, 10 times 19, and you can use your calculator if you want to. 10 times 19 is 190. Then we can use our calculator. 38 times 5 is also 190. So we can say, yes, they are equivalent. So the ratios are equivalent. And that is how you go through and decide if those ones are equivalent. I'm going to have you go ahead and work through number 4. and bring your questions to Zoom if you have them. But go ahead and pause the video here so that you can work through part 4. All right, you're ready to move on to IXL H5, looking at unit rates. And we're going to go ahead and look at IXL really quick so you can see how that works. Okay, I've already got it pulled up, and I have this posted. This is just the learn from or click to learn more at the beginning of each unit. We're at H5 unit rates. And so the question is going to look like this. Find the unit rate. You have 39 passengers on 3 buses. So you're trying to figure out how many passengers you have per bus. So if you have 3 buses and you have 39 passengers on 3 buses, we're going to divide this first number by the second number in order to find the unit rate. So a unit rate is a rate where the second amount is 1 unit. So rather than 39 for 3 buses, we want to know how many passengers are on 1 bus. We're making the assumption here that they are all equal. There's an equal amount on each bus. So all we need to do is divide. 39 divided by 3 equals 13. 13 passengers per bus. So let's go ahead and look back. You may not need to write anything down for this. It's kind of up to you. But in this question, we want to find if there are 16 plates in 2 stacks, then how many plates are in each stack, assuming they're both equal. So in this case, we're taking 16 and we're dividing it by the 2 stacks to see how many are in each stack. So we could do that with mental math and find that it's 8. If there are 30 chairs in 2 rows, and assuming they're both equal, how many chairs per row? Well, 30 divided by 2 is 15. Same here. Find the unit rate. If you're going 30 kilometers in 30 minutes, how many kilometers are you going per minute? So we take 30 and divide it by 3, and we know that we're going 10 kilometers per minute. If you read 16 pages in 2 days, how many pages are you reading a day? Again, assuming they're all equal. 16 divided by 2 is 8. Same, you're going to divide 48 by 6. So I think you probably know how to go and do it. You're going to divide to make it so the second number in the ratio is 1. So you're going to divide the first number by the second number. Go ahead and do that all the way through, and then come back and join me when you're ready to move on to unit H6. Okay, if you're ready to move on to IXL H6, word problems involving ratios, I'm going to go through that with you in IXL. And this is going to take some time. It's more a practice of your reading comprehension than it is of you being able to do the ratios. The ratio skills are the same ones that we've been learning. We're going to go ahead and switch to IXL so you can see. Okay, so here we are in H6, word problems involving ratios. We're going to look at their example, and then we're going to solve some on our own. Dan is making a model volcano for the science fair. He wants an awesome eruption, so he tries different amounts of baking soda and vinegar. First, he tries 2 tablespoons of baking soda and 6 tablespoons of vinegar. Next, he tries 3 tablespoons of baking soda and 9 tablespoons of vinegar. Did Dan use the same ratio of baking soda to vinegar in both eruptions? Okay, so the first one, he used 2 tablespoons for every 6 tablespoons. And in the next one, he tries 3 tablespoons to every 9 tablespoons, baking soda to vinegar in both of those. So we're going to look at the ratio of those 2 numbers. So we're comparing 2 to 6 to 3 to 9, and we're seeing if the ratios are the same. In order to do that, we're going to start by finding the ratio for each one, which is what we just talked through. So in his first eruption, Dan used 2 tablespoons of baking soda and 6 tablespoons of vinegar. So his first ratio was 2 for every 6. 2 tablespoons of baking soda for every 6 tablespoons of vinegar. In his next eruption, Dan uses 3 tablespoons of baking soda and 9 tablespoons of vinegar. So his ratio for the second time was 3 to 9. Now we're going to do the math that we've done already. We've done the sleuthing part, we've read through it, and we've figured out the ratios, and now we're going to go ahead and do the math with it. So now we're going to check to see if they're equal. There's 2 ways to do it. One of them is to write them out and rewrite 2 over 6 and 3 over 9 using a common denominator. That is a multiple of 6 and 9, like 18. So just like we did in some of the early sections, we can go and find a common denominator. So if we're trying to find a common denominator, we know that 9 and 6 both go into 18. So to get 6 to 18, we're multiplying it by 3, which means we have to go through and do it on the top. And to get 9 to 18, we're multiplying it by 2, which means we have to do that with a number on the top as well. So we get 6 over 18 and 6 over 18, and we find that those are, they are in fact equal, meaning the ratios are the same. We can also rewrite 2 over 6 and 3 over 9 as simplified fractions. So we can do 2 over 6, and we know that we can simplify that further. We can divide 2 by 2, and we can divide 6 by 2 and get 1 over 3. Same thing with 3 over 9. We can simplify that further and just simplify the fraction down as much as we can. So we can either do finding a common denominator, or we can go ahead and just simplify the fractions down as low as we can and see if they're equal. So in this case, yes, Dan used the same ratio of baking soda to vinegar in both eruptions. We're going to go ahead and start another one. Let's go back to practice. This is the one that we're going to look through on the dot cam. So Darnell and Lester took a fishing trip with their scout troop last weekend. Darnell, I'm going to write down as we go. Darnell caught 4 catfish and he caught 8 trout. And then Lester caught 3 catfish and 6 trout. Now, what we're going to do is decide if they caught the same ratio. So I'm going to switch over to my document camera and we're going to solve this together. Okay, so I've got it written out. I had accidentally made a mistake there. I wrote caught instead of catfish, so ignore that. So Darnell caught 4 catfish for 8 trout, and Lester caught 3 catfish to 6 trout. So we're going to take those, and we have the ratios of 4 to 8 and 3 to 6. Now we have our ratios, and we can write those as fractions. So what I would do in this situation, because I can simplify those numbers pretty well, is I'm going to choose to simplify the fractions. So first, let me write them as fractions. I have 4 over 8, and I have 3 over 6. Okay, so if I want to simplify these, I know that I can divide each of these numbers by 4 to simplify them. So I could do 4 divided by 4. Which means I also need to divide 8 by 4. And I will get 1 over 2. Now I can't simplify that any further. You might be able to do that in your head, especially with 2s. Sometimes I can go and do those really quickly. Same thing down here. I know that 3 goes into both of those numbers, so I can divide 3 by 3. And I can divide 6 by 3. Oops, sorry. There we go. And I get 1 over 2. I know those are equal, so yes, the ratios are the same. All right, let's look at another one. We're going to use a different strategy to solve this one. So in this case, Amelia and Darnell are arguing over who makes the best fruit punch. Amelia likes to use 2 cups of grape juice for every 5 cups of pineapple. Darnell prefers to use 1 cup of grape juice for every 4 cups of pineapple juice. Do Amelia and Darnell use the same ratio of grape juice to pineapple juice? So we're going to switch over and look at the whiteboard, or sorry, at my document camera, so we can do this together. I already wrote out the pieces. Amelia has 2 cups of grape juice for every 5 cups of pineapple juice, and Darnell has 1 cup of grape juice for every 4 cups of pineapple juice. Okay, so remember, a ratio is a comparison of 2 numbers that have the same unit of measurement. So we're going to compare these 2 numbers that we're measuring the same. We're using cups. So in order to find out if Amelia and Darnell use the same ratio of grape juice to pineapple juice, we're first going to find the ratio itself of each one. So we know that Amelia's ratio is 2 to 5. And Darnell's ratio, excuse me, is 1 to 4. And we're going to easily put those into fractions, knowing that the first number is the numerator and the second is the denominator. We're going to do that down here. Let me see if I can leave it so you can see it all. There we go. Okay, so the first number is 2 over 5, and that's Amelia. And then Darnell's number is 1 over 4. You might be able to see those and know those are not equal. And that's okay. If you know that your ratios are not equal, you can go ahead and answer the question from there. But let's go ahead and walk through and practice how you would find that if you didn't know, okay? So the first thing that we're going to do is rewrite them using well, we did the common denominator before. So you can also do, another option is to do it in decimal form. So that's something you can do quickly on your calculator. You can easily divide 2 by 5 on your calculator if it seems like that would be the easiest thing for you, and you would get 0.4. You can also just divide 1 by 4, and that equals 0.25. So that is rewriting in decimal form. That is another strategy you can do to see if those 2 ratios are the same. And are they? No, they are not. Okay, they are not equal, so they are not the same ratio. Remember, the simplified fraction or the decimal number has to be the same number in order for them to be the same ratio. Okay, so I've shown you a couple ways how to do this. As you go through IXL, you might double check and see if you like a certain strategy more than another. I'm going to let you go ahead and work on this section, and we're going to come back when it comes to H7. So go ahead and pause the video and we'll move on to H7 when you're ready. All right, we're going to start H7, solve proportions with word problems. So I have this open in IXL. We're going to go ahead and look there. What we have here in H7, solve proportions word problems, is an example of how you can solve it. So basically I went on the first one, learned by an example, just like I tell you to do each time if you're working on your own without me. So I'm going to talk you through what this is saying, and then we're going to practice some together on the dot cam. So Alana's graduation picnic will cost $14 if it has 7 attendees. At most, how many attendees can there be if Alana's budgets a total of $16 for her graduation picnic? Assume the relationship is directly proportional. So we're going to look back at the way that we were making equal ratios. So it's kind of the same thing, but we're using this word proportional. Okay, so we're going to set up and solve for letter N. However, this is exactly like what you just did when you were solving for the missing number in, I'm trying to remember which section it was, writing an equivalent ratio, so in H3. So rather than just a blank spot when you're making an equivalent ratio, we've changed that blank spot into the letter N. So if you think about that in your mind, that might help you. So we're setting up the proportion. So we know that for $14, with $14, she can have 7 attendees. So then what can she have for $16? Assuming it's equal, it's an equal expense for each attendee. Okay, so what we can do first is we could in our mind maybe figure this out. But there's another way we can do it if we go through and do the math. So we're going to talk about both of those options. So in this case, we're actually doing, this looks confusing the way that it's written with this 7, with multiplying each times by each side by 7n, but really all you're doing is that cross multiplying that we practiced before. So you're taking 14 and multiplying it by n, and you're doing 17 and you're multiplying it by 16. Okay, so we're going to do 14n equals 16 times 7. We're cross multiplying. And then we're going to do some algebra that we haven't done a lot of this year, but you guys have done it before. So we're taking 14n. We're going to bring it down because we're not doing anything with that side yet because we're solving for n. But we can do 16 times 7. 16 times 7 is 112. And then we know that if there's a number multiplied by a variable, we can, and then we have the whole number over here, we can just divide both sides by 14 to get 14 moved over to this side. So we're going to divide 14n by 14, which will cancel out the 14 and leave us n. And then we're going to divide 112 by 14, which gives us 8. So the way that this is written looks really confusing, but as you keep going, hopefully it feels like it makes more sense. In this case, the answer is if Alana budgets a total of $16 for her graduation picnic, there can be at most 8 attendees. So we're going to go back and do a different question, and hopefully with some of my examples, it'll also make sense. Bryant took a total of 12 quizzes over the course of 16, sorry, let me start again. Bryant took a total of 12 quizzes over the course of 6 weeks. How many weeks of school will Bryant have to attend this quarter before he will have taken a total of 20 quizzes? Assume the relationship is directly proportional. So that means we're assuming that he takes the same amount of quizzes every week. That's what it means by assuming that the relationship is directly proportional. I'm going to go ahead and write this down on the dot cam, and we're going to solve it there. Okay, so we have it written down here, H7, solving problems with word problems, solving proportions with word problems. This is the proportion that we're working on from IXL. For every, sorry, I forgot the name of the kid. Let me look back really quick. Bryant, that's right. Bryant took a total of 12 quizzes over the course of 6 weeks. So how many weeks of school will he need to go to before he's taking a total of 20 quizzes? Okay, so we're going to go through and we're going to set up the proportion to solve for n. So I'm going to go through and talk about the, I'm going to talk about a step we haven't talked about before, or a strategy, I should say. We've done cross multiplying, but if we have 12 quizzes for every 6 weeks, we're deciding if that is equal to, oh, no, sorry. Got stuck doing the wrong thing. We need to find out how many weeks Bryant will be in school when he has done 20 quizzes. So this is just another way to write this ratio. We're writing it more as a proportion. Okay, so we're going to move that down to 12 over 6. And then we've got 20. And then we have n, which is our number that we're looking for, okay? So this is our variable that we're trying to solve for. Now, what we can do is multiply both sides of this equation by 6 times n, because we're multiplying it by the 2 denominators. Okay, this is something we haven't done before, so we're going to look and do it together. So we're going to multiply 12 over 6 times 6n, which is the same thing as 6 times n. And we're going to multiply 20 over n by 6n. Okay, so this is something we have not done before, but it's actually pretty simple. So let me talk you through it. If we're only looking at this side here, we're looking at 12 over 6 times 6 times n. In this way, we can cancel out the 2 6s. Okay, and we're going to be left with just 12n. And that's going to be similar to over here. We're going to cancel out the 2 n's. And we're going to be left with 20 times 6. Okay, this is a step we haven't done before, but we're going to practice doing it more in class as well. So here we have 12n equals 20 times 6. So we're still trying to solve for n. So the next step we're going to do is 12n equals 20 times 6, which is 120. Okay, we've gotten it solved as far as we can on the right side, and now we need to get this 12 over to this side. So what we're going to do, since it's 12 times n, we know that we can divide this whole thing by 12 in order to get rid of the 12 here, because that would cancel it out. But since we did it over here, we have to do it over here and divide 120 by 12. That's going to leave us with just the n on this side of the equal sign, and then we can just solve 120 divided by 12, and we get the number 10. So we can go ahead and plug that into our original here, where we were looking for every 6 weeks, there were 12 quizzes, so 12 quizzes over 6 weeks. So we know that there's going to be 20 quizzes over 10 weeks, because we just did all of that math to figure it out. All right, we're going to do one more. We're going to use the same exact strategy. Here's the problem from IXL. Aubrey read a total of 16 books over 4 months. After belonging to the book club for 5 months, how many books will Aubrey have read in all? Assume the relationship is directly proportional, meaning she's going to read the same amount per month. We don't have to worry about any variables there. So if she reads a total of 16 books over 4 months, how many books will she read over 5 months? We're going to go ahead and put that on the .cam. I already wrote down the notes for us, so I'm just going to get switched over. Here we go. Aubrey read 16 books over 4 months. So how many books does she read over 5 months? So what we're going to do is we're going to make sure we write those as a proportion. Okay, so we have 16 books over 4 months, and that's going to be proportional or equal to n books. Remember, this is the variable we're looking at, over 5 months. Okay, and we're going to use the same strategy that we used before. We're going to multiply both sides by 4 times 5, because remember, we're multiplying our denominators, okay? So this is something we haven't done before. We just did it in the last one as practice, but we're going to take 16 over 4 and multiply it by 4 times 5, and that is directly proportional to n over 5 times 4 times 5. Okay, this seems very complicated. It's really not. It's the same thing we just did. We took the two denominators, multiplied them by each other, and then we're multiplying that by the overall fraction on either side. So if we have, we're just going to do one side of this at a time. Let me grab a sticky note really quick, okay? Because really, we're going to figure out what's on both sides of the equal sign first, okay? We're going to simplify this down as far as we can. So if we have 16 over 4 times 5, we know that if we're dividing and multiplying 4 in the same equation, we can just cancel those two out, okay? So we're going to be left with 16 times 5. And then we know we can simplify that down to 80. Oh, I didn't write the 16, sorry. 16 times 5 is going to equal 80. So we've simplified everything on the left side of the equal sign. We've gotten that down as simple as we can. Now we're going to do the right side of the equal sign. Okay, we don't have to worry about this side yet. We're going to simplify this down as far as we can. We know we can cancel out the 2 5s. Okay, and we're left with 4 times n or n times 4, either one. 4 times n. Okay, that's all we can do on this side. We can't do anything else until we finish solving everything on this side. So we're just going to bring 4 times n down one more time. It's as simplified as we can make it without having to deal with everything on this side. But we had to make sure everything on this side of the equal sign was also simplified. So now we want to get this 4 over to this side of the equal sign. So we need to divide, since it's 4 times n, to cancel it out, we have to divide by 4. So now we can cancel out the 4's here and divide 80 by 4, okay? So on the right side, we've canceled everything out and moved it all over to the left, so all we're left with is n. But on the left side of the equal sign, now we have to divide 80 by 4. And 80 divided by 4 is 20. So now we can go back to our original, when we were looking at 16 books over 4 months. Now we know this n number that we were looking for is 20. We can do all that math and figure out that she will read 20 books over 5 months if she's read 16 books over 4. I'm going to go ahead and let you continue working in this. I expect that we can work through some of them together, that there might be some questions. So please bring your questions to Zoom if you're distance learning, and I will be ready to help you. But go ahead and pause the video, and I'm going to move on to the last portion, H7. All right, I said we were moving on to H7, but I actually meant H8, which you guys probably knew. But we're going to look at H8. Do the ratios form a proportion? So what we're going to do first is look back at IXL and go through their outline of how to do it. Okay, so we have H8. We're on the first question where we're going to just click Learn with Example right away and learn and read through what we're doing. So let's make sure we understand what they're asking. Okay, so if 2 ratios form a proportion, that means that the 2 ratios are equivalent. Equivalent ratios have to have the same value. So we're saying, are these 2 ratios of equal value? Are they equivalent to one another? Now, here we go in and we're going to determine if they are a proportion. So if they have an equivalent value. So one of the ways you can do that is to compare them using a common denominator, which is something that we've done already. In this one, you can see that we've taken the 2 proportions, 18 over 10 and 2 over 1, and we are going to first find the common denominator. So since 1 is one of them, it's very easy to get a common denominator. So we can just multiply 1 times 10, and then we can multiply 2 times 10. So here that is written out right here. So in order to get to the common denominator of 0, we're going to multiply 1 times 10, and we're going to multiply 2 times 10, which equals 20 over 10. The other ratio was 18 over 10. So 18 over 10 and 20 over 10 aren't the same. So we know that 18 over 10 and 2 over 1 are not the same. So they do not form a proportion. They do not have the same value. They are not equivalent ratios. Okay, so we're going to look here. Do the ratios 3 over 6 and 1 over 2 form a proportion? I'm going to switch over to my camera so we can look at that together. Okay, so we have the ratios 3 over 6 and 1 over 2. We're going to try and compare them using a common denominator. So the denominators are 6 and 2, and we can use 6 as the common denominator because 6 is a multiple of 2. So we're going to leave 3 over 6 as it is, and we're going to change this ratio into a fraction with the denominator of 6 so we can compare it to this. So 2 times, we're going to do it this way. Okay. We know that 2 times 3 is 6. So we're going to multiply the top by 3 also. So 1 times 3 is 3. And now we know that 3 over 6 is the same as, or it's an equivalent ratio to 1 over 2, because 1 over 2 is the same as 3 over 6. So that means, yes, they form a proportion. Because that means that these two ratios are equivalent and they have the same value. So when we go and do these problems, we're going to go and see if the two ratios are equivalent. We can do that by finding the common denominator. We're going to do it one more time. Let's find out if the ratios of 1 over 2 or 1 for 2 and the ratio of 6 to 12, if they are a proportion. So we're going to find out if they are equivalent ratios. So we're going to do that by finding a common denominator. We know that 12 is a multiple of 2, so we can keep 6 over 12, but we need to change this top one to equal 12 as the denominator. So 2 times what is 12? 2 times 6, okay? So then we also need to multiply the top number by 6. So 1 times 6, 6 over 12, okay? They are the same. They are equivalent ratios. So we know also this one, yes, forms a proportion because the two ratios are equivalent and they have the same value. You can go through and continue doing this for all of the questions in this section, and this is the last thing that is due this week. If you have any questions, please feel free to bring them to Zoom or set up a different meeting with me, and I'm happy to help.